This is SIA AS1 Physics, January 2013. So this here is just talking about a question where you have a spring with a mass attached to one end and it produces a force. And whenever we pull down the spring with the force attached, it will then begin to oscillate. So it tells us here that T is the periodic time, the time for one oscillation. The mass is the mass attached to one end of the spring. The force is the force in the spring due to this mass being attached. And X is, does it tell us what it is? No, it will just be the displacement that the mass has been released. So basically they want us to find base units of X. So first of all, we have to get this equation and we have to rearrange it. So at the minute we have the square root of X. To get rid of the square root, we're just going to square everything. So that become T squared equals mx over f. Now because we're looking at units, 2 and pi do not have any unit, so therefore we can ignore them. So this is what our equation looks like. Now we have to rearrange it for x. So at the minute, x is being multiplied by m and divided by f. So this is like a very simple triangle which we've drawn out here. So we have mx in the top, t squared on one side, the bottom, and f on the other. And I'll just rearrange this for mx first, put your phone number what you want. So mx is equal to t squared times f. Remember, this means multiply and this means divide. So mx is equal to t squared times f. But I don't want m times x, I want x by itself. So if it's being multiplied by m, to get rid of it, we have to do the opposite. So we have to divide by m. So x is equal to t squared f over m. So that's great. We've now rearranged the equation. Now what we have to do is we actually have to put in our units and work out the units for x. So the first part's easy. T is a time and it's squared. So that is just simply seconds squared. So I'm just going to write units here. So it's seconds squared. Force is measured in newtons. Newtons is not a base unit, so therefore we have to think of an equation for force. I always think F is equal to ma, my mass times acceleration. And then the units for that. So my mass measured in kilograms, my acceleration is measured in meters per second squared. They're all base units, so that's fine. So I'm going to go and put this back up here. So that is kg m s to minus 2, and my m is my mass. My mass is measured in kilograms, so it's divided by kilograms. So now all we have to do is just tie it up. So the kilograms cancels out with the kilograms on the bottom. Seconds squared plus s to minus 2, so a positive 2, take away 2, it's going to cancel these out and be 0. So I'm left with meters. And meters is my base units of x. And as I said, x is the distance the spring was going to be displaced. Distance is a length, which is measured in meters.